All right, got my triangle hat on. Going crazy about triangles now. So this is the game plan at Schoology. This is also the game plan. If I was in class, we wouldn't dive into these notes, the notes that you have here, which is going to be 713B. We wouldn't do this until I give you time in class to work on some homework that relates to proofs on here. So you should be doing the part B of the homework in here. This beauty right here. We're doing this first. You'll notice this doesn't have steps numbered on it like I did with the previous assignment, part A. This is all doable. You can do all these. I give this to my regular Math 1 class when I teach regular Math 1. My Math 2 class this year did this as a review. So these are all doable. You should do this first, as it says in Schoology, before you try to go on to part C, just so you understand the letter order on here. Even though these B notes look like it's something different, you can do the homework without this. The part C homework, you need this. Because right now, you probably think there's 4 ways to prove triangles are congruent. However, there's another way. What you don't know is there's a 5th way. You know side, side, side. And jot down 4 of those that you know. You know side, angle, side. You know the 2 that have double angles, angle, side, angle. Of course, the last one must be ASA. Yes, it's angle, angle, side. Good job, ASA. So you know both. You know those 4. The one you don't know is the weird-looking one. It wouldn't work for this type of triangle, and I don't criticize that's a little curved on there, but it wouldn't work for this type of triangle. HL is in fact a 5th way. It only works for right triangles. They'll give you a hint at what the H and the L stands for. Because there's something that right triangles have that acute triangles and obtuse triangles do not have. And that's this H thing right here. H is not standing for height. H stands for, whoops. As soon as you know that's a 90-degree angle down there, you know that this side is special. So special it gives its own fancy name. That's a hypotenuse. And if that's the hypotenuse, is actually a fancy name, a simple name for these two, called a leg. This is called the HL theorem. Now, technically, this is 3 parts, 3 parts, 3 parts, 3 parts. There actually are 3 parts. When you say the word hypotenuse, you are implying that you have the right angle. So the 3rd part of this is the right angle. Put a little R there. You still have 3 pieces of information. But it's not side angle side because there's a side, there's a side. The angle's not between those two angles. It's not that angle. It's the right angle over here. And you're not going to call this angle side. I'm not going to write it. You're not going to call it that. That would be a naughty way to write this. And we want to clarify that it's not just for any old angle. It's only for right angles, which is why we call it the hypotenuse leg theorem. Used to call it the donkey theorem in my class. So there it is, the donkey theorem. Bringing in Donkey to introduce this thing. Here's what it looks like visual. You have to know those right angles. That's one thing that has to be known on there. Of course, we know that's called a hypotenuse. These ones are called the legs. Whether you think of them as base and height, you can think of them that way as well. So you'd have to know that the hypotenuses are congruent. Check. Got that piece of the puzzle. You'd have to know that one of the legs, either this pair or that pair, either one. That's what hypotenuse leg is going to look like visually. In terms of a sentence, you can fill this in with a big word followed by a small word. So if the hypotenuse and one of the legs, either leg, doesn't matter which one, of a triangle, of a, what kind of triangle? That would be what I'd ask in class. Oh, of a right triangle. It's only works for right triangles. So I've got the 3 parts in the sentence on here, captured. Congruent to that's the same thing of another triangle. Saved a little bit of writing. Again, you conclude the triangles are congruent. This is a 5th way. Slightly different. Don't want to forget about it. It works. Again, it's a theorem. Makes it a little different. The reason it's a theorem, you could prove this using the other postulates. You could prove this and justify it using the other postulates. The other thing you can notice, because we already talked about Pythagorean theorem, if you know two sides of a triangle, you can use Pythagorean theorem to find the third side. It's another way you could prove that this theorem in fact works. So there's 5 drawings on your paper. I want you to state the triangle congruence theorem or postulate. I should put that on here. Not that it really matters. You know, which of those theorems is going to apply? You need a bunch of givens. There's your givens. And there are people that will try to jump to those conclusions right now. They go, well, this one is for sure, and that one is, because they have right angles, and they all. Whoa, there's not. All you know right now is that these two triangles, they share one side. They have one neighboring side on there. There's your givens. So this is a good time to pause it. See if you can come up with a conclusion for all 5 of these, but why those triangles have to be congruent. A quick little explanation for it. So if I was in class, I'd ask, hey, you got 2 parts. There's, they both have congruent bases. They both have a right angle in this case. Is this hypotenuse leg? And people go, well, no, it's not hypotenuse leg because you don't know anything about the hypotenuses. So is there a way to do it? Of course there is. You got a shared side on here. You got a side, an angle, and a side. Congruent to a side, a right angle, and a side on there. So all 4 of these have the shared side. I've just shot that piece of information up there, which is certainly helpful. Most of these are not hypotenuse leg. There's my donkey showing up on here. And a lot of people will try to like HL for all of these. This one, clearly not. This is the only one that's hypotenuse leg. You got the hypotenuse is congruent. You've got that shared side. You got a right angle. You could prove this another way as well. I might ask in class what type of triangle that one is. And somebody would say, well, that right there is an isosceles triangle because the 2 sides are congruent. And if it's an isosceles triangle, what else do you know about it? Oh, you know that angle and that angle congruent by the isosceles triangle theorem. And now you could use angle, angle, side, or angle, angle, side. That would be perfectly fine. I just want to show, which is technically we just proved hypotenuse leg works by using angle, angle, side to build upon that. So some of these could have more than one answer. The homework for 13C tells you to name all of the methods. So if there's 2, put them both. If there's 3, put them both. And some of these will have more than one method in there. This is sort of a classic angle, side angle example. The one down here is a classic can't do it. And people will argue with me that you can do it. This little side here is definitely shared, but we don't know if it's a pendulum and it's tipping back and forth. If this were to tip a little bit that way, this angle is now smaller than that one. And they'd still have pair of sides and pair of angles on there. This is isosceles as well, the big triangle. That still doesn't give you enough information. Let's do that in black. That still didn't make these 2 angles are the same. You would need more information on this. You'd have to know that's bisected, that those are right angles. And no, I looked really close. I still can't prove the right angle, so I can't get a conclusion on that. There's just not enough information. Sorry. And kind of the same thing on this one. There's something very important missing. I do have 2 pairs of angles, congruent to 2 pairs of angles. You always have to have a side length. Always have to have a side length. So there's nothing saying that this triangle is the same as that triangle. They're both isosceles triangles, true. Whatever this length is, it's congruent to that length. But this could just be a scaled version of this one. This could be a slightly smaller version. This thing could be 17.5. And this one could be 17 and 17. And that could be true. They're the same angles. They're both isosceles. This is just a bigger version of that one. So don't have enough information. You always need a side length. Oh, there's some numbers there. There's a possibility. Oh, I guess I'll leave that up there. So this is a nice one. I'm going to erase that stuff for a moment. I did this last time. Nice colors there. I don't know if those are what country? Cameroon. Cameroonian colors, I believe. So a little proof. 3 givens. This is more of an honors level proof on here. Maybe to add little segment lines on those. This is a great spot to pause. Go for it. See if you can prove it. I'll be back in part 2 in just a moment. And you'll see I've staggered these a little bit to separate them. You can do it any way you want.